What's up? You should watch this one. Weird. Here it is. Worksheet. This is quiz 2A. 2B to come soon. You can find this right in, it's called a worksheets and test prep. It's going to be called reference angle worksheet. So this will be the module, and this will take you to the PDF. And you're going to need to fill it out. There we go. Quiz 2A. It's hanging out right underneath the little module, worksheets and test prep. You know, right below the videos that you're watching right now. Go look down there. The name of it is, one more time, you want to see it, reference angle worksheet. And that's going to be this PDF right here. Look at it. It says reference angle worksheets. Like, that shit matches. A little spot for your name. And I'm going to do a few we're going to talk about. Now, degrees doing reference angles, they suck. Some of them, because I know the numbers already, they're not so bad. So the directions here say the first thing we should do is see if we can't find an angle coterminal to the angle that's between 0 and 360. Now, that does not apply to this, or this, or this, or this. You don't need to do that for any of these. That's unnecessary. But you would want to do it to something like this. Because I don't want to solve shit about 7,440 degrees. I'm just not interested. I would much rather be able to solve it as something smaller. And I'm going to show you how to do this problem. 570 is another one. 3630, 510, negative 225 degrees, 1,234. These that are larger than 360 degrees or smaller than 0 degrees, let's go find their coterminal angle. And that's why I asked you to do that first. So, okay, that's done. We talked about that. Oh, shit, this is getting crazy. Sorry. Now we need to determine how many degrees from the x-axis the given angle lies, since we're in degrees. Oh, let's just jump in. I'm going to do the first one. 210. Do you know that 210 is bigger than 180? Because we just have to know this. 180, 360. All right? Oh, well, this is 0 as well, right? It's 0. But I'm just going to write the 180 and the 360. We go, all right, where's 210? Oh, whoa, wait a second. What if we wrote this in? Yeah, now we're up to something. So where's 210 go? Somewhere over here. Here's 210. Now, how far back to 180 is it? How far? What's the difference between 210 and 180? I think that's 30 degrees. There's the game. All right, let's do C. Let's do C. We'll go get this. Let me draw it in again. Let me put all 90, 180, 270, and then I'm going to write 360. We don't give a shit about the 0 in this game because reference angles are already in the first quadrant, so I don't want to write that down. Coterminal. So 330. You're like, I wonder where 330 could go. Well, of course, it's going to go between 270 and 360, so I'm not drawing this to scale. I just draw it out. There's 330. How far back is it from 330 to get to the x-axis? Not back to 180. Not the 180, just the x-axis. And that's 360. Well, that's just 30 frickin' degrees, isn't it? Oh, shoot, we got the same frickin' answer. So you're either going to be taking away from 360, taking away from 180, or taking your answer and taking a 180 from it. Now let's keep going. I'm working my way on down. 7,440 degrees. It's too big. Now, I don't want to do this forever. Like, well, that's going to be carry the... Nah. I'm going to take away bigger multiples. So I'm like, wait a second. This thing is in the thousands. So I'm going to start off with this. What happens if you were to spin around in a circle 10 times? Wouldn't you get 3,600? Isn't that true? 10 times center mass Earth. Just add another 0. Well, what's two 360s? What's that? What's two 360s? Two 360s is 720. Right? 360 times 2 is 720. Now, what happens if you were to do 10 720s? When you get 7,200 degrees? All we want to do is subtract multiples of 360. Remember, spin around in a circle, go back to the same spot. That's coterminal. So let's not use this shit that's on the left. Let's use this one that's on the right and be like, oh, bro, just subtract 7,200 from it. And what's left over? 240 degrees. Now we can play this freaking game. Now we got some shit that's in between 0 and 360. It's like, let's go. Now, if you can just start playing this game, you don't have to draw this picture every time and be like, what's the difference between 240 and 180? 60. Your answer's freaking 60. But if not, as we're learning, we're like, okay, 270, 360, 180. All right, so we're going to take our 240. We're going to pop it right in there. Like 240. Now, what's the difference? 60 degrees. Because the difference between 240 minus 180 is indeed equal to 60 degrees, no matter how you look at it. Cool. I'm purposely not doing any of the second quadrant. I'm going to leave that up to you to try and logic that stuff out, like 135, something like that. Cool. I don't want to do too much talking on degrees because I don't use a ton of degrees. So I'll let you do the rest. I just give you a little hint here. Hey, dude, maybe add something there to get it between 0 and 360 degrees. Then go find your reference angle. Maybe that. I guess I'll do a quadrant too. So there's your little hint for J. Let's do 123 down here at K. I'm going to say 123. Well, that's got to be between what? 90 and 180? Our quadrantals. We draw it in. We're like, 123. Whatever. Just put it there. And we want to know, well, how far to the closest distance to the x-axis in degrees. Well, the difference is just going to be 180 minus 123. That's the difference. We don't care about the positive or the negative. Just take the absolute value. If you just find the difference, you subtract one shit. Even if you're punching it in your calculator and you get a negative, just change it to a positive. As long as that thing's between 0 and 90 degrees. We do some subtractions and we end up with what, 57 degrees? 57? Am I right on that one? I hope so. But that's between 0 and 90 degrees. Just like 60 was between 0 and 90 degrees, so was 30 between 0 and 90 degrees, and so was 30 degrees between 0 and 90 degrees. Yeah, so I've done a lot of this freaking worksheet for you. Do the rest. Now radians. Oh, let's do radians. Again, this says find any coterminal angle between 0 and 2 pi if necessary. You know what's cool about radians? It's almost never necessary. I'm going to do just quite a few of them for you here. I'm actually just going to run through and I'm going to do the first 5. F it. I'm just going to get weird. If your denominator is a 3, a 2, a 6, or a 4, those commons, bro, here's the game. 4 pi over 3. 4 and 3 do not reduce down, all right? 4 pi over 3, hence the reference angle is pi over 3. Let's go to the next one. 321 over 2. That doesn't reduce down, an odd number over an even number. So we're just going to take this and go, we'll take that shit. Alpha is equal to pi over 2. Let's go to our next. We have negative 11 pi over 6. Oh shit, do we need to add 2 pi to it? And no, we don't. No, we don't. We might later, but for the reference angle, bruh, it's pi over 6, because 6 doesn't go into negative 11. Oh, lowest looking number, let's look at D. Oh my gosh, that thing's going to go around in a circle like at least 1.5, like it's going to be like, not 1.5, but almost 1.5 times. But I don't give a shit about that. I just look and go 17 over 6, that doesn't reduce. Alpha is equal to pi over 6. Now this is only true, again, when your denominator. This is true for pi's over 2, pi's over 3, pi's over 4, and pi's over 6. This game will not work for other freaking numbers other than that. And I'm saying just different, like 11, 13, 15, 17. Nothing that will reduce. you'll always get the reference angle. I've shown it to you pictorially. Now it's just the how-to. Now here's our stumbling block. Let's go to E. I told you I was going to do the first 5 for you. And we look at this, and if you jump the gun too quick, you're going to say, oh, pi over 6, and you're actually going to be incorrect. The reason being, 111 is divisible by 3, and so is 6. You can tell that 111 is divisible by 3 because 3 has a special division trick. If you take all the digits, 111, now add them up. 1 plus 1 plus 1. Is that number 3? Is that divisible by 3? Yes. Therefore, it's divisible by 3. So you add up a bunch of digits like 1, 2, 3, 6. 1, 2, 3, 6. This number, I know it's divisible by 3 because 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 6 is 12, and 12 is divisible by 3, so the whole thing is divisible by 3. Just number sense. Just number sense. So, like, wait a second. We're going to get negative, and by the way, I think it's 37 times 3 times 5. And we don't care about that 37. I don't give a shit about that. And then we go, oh, the 3's go away. Now what's left down in that denominator? Pi over 2. Hence, our reference angle is pi over 2. And that's technically pi over 2 or 90 degrees. Technically, that's not a freaking reference angle because it's not a cube. But for the nature of this game, it's called a reference angle worksheet and it tells you to find the reference angle, but really I'm just saying find how many radians from the x-axis the given angle lies. So technically 0 and pi over 2, or 0 and 90 degrees, not technically, but for what we're doing, we're all good. All right, so I'll mess around with F. Look at G. What's up with H? 1 plus 4 plus 1. I, J, and I'm going to do K. Because this is not a pi over 6. Now this is just an extra game to take you a step further, to make certain that you understand how to do reference angles. 10 pi over 7. Now I'm going to draw this thing. And if we learn this little game, it's pretty dope. We're like, all right, pi, 2 pi. Since our problem has a pi over 7 in it, I'm going to change it. I'm going to just like, no, make that 7 pi over 7. It makes it easier to find stuff. So I don't want to write 2 pi as 2 pi. I want to write that as 14 pi over 7. I want to write that 2 pi, right? 14 divided by 7 is 2. And then what's half of 7? I can't remember. What's half of 7? Isn't that like 3.5? Don't you all love those decimals and stuff? So I'm going to miswrite. Oh, come on. I'm going to miswrite and put it in as 3.5 pi over 7. Half of the freaking thing, half a pi. 3.5 plus 7 is 10.5 pi over 7. Now it tells us which freaking quadrant we need to put this. This is a much trickier game. If I give you a 9 or a 10 or an 11, man, the game gets rough. So now we just make our line. 10 pi over 7 is here. So how far back to the x-axis, how far is it from 10 pi over 7 to 7 pi over 7? How far is it from 7 to 10? 3. It's 3 pi's over 7. This is a tricky one. That's the tricky. It doesn't pop up. Make sure you can do the game very often. Make sure you can do the first like 10. Those are solid. After that, do your best. So there it is. One more time. This is quiz 2A. Worksheets and test prep is the module. Reference angle worksheet is the PDF, and you can get your own. I've done a few of them. Good luck. I will see you soon.